Alright, geometers, today we are going to go over tangent lines, and through problems 12.15, 12.16, 12.17, I will show you the three things you need to know about working with angles and circles that have tangent lines. This painting by George Watts from 1902 is called The Sower of the Systems, which features a face-hidden God sowing the systems of the universe. Alright, first though, before we jump into tangents, let's review. Looking at my diagram here, if I want to find the green angle indicated, what do I need to do? What is the formula? Well, if you were paying close attention last time and did your homework studiously, you will recall that x plus y over 2 gives us this angle. Similarly, if my angle is outside the circle and I have two secant lines that meet, my formula is b minus a over 2. And you can see those formulas here. To find an angle, you need the arc x plus arc y over 2. And to find the angle outside of the circle, you need arc b minus arc a over 2. Alright, so cement this in your head, put this in your notes, and make sure you memorize how to employ it. It's quite simple, really. Just pay attention to which arcs are the arcs you need to identify. The first thing you need to know about tangent lines is that a tangent line meets the circle in only one point, and there is therefore only one radius line that meets the tangent line. The point where the radius line of a circle and the tangent line meet will always be the point where the radius and the tangent line meet will always be a right angle. So next, let's open your books to 12.15. On 12.15, we are given that arc AB is 80 degrees, and we need to find angle BAZ. What this problem will indicate for us, once we have solved it, is a general formula for finding angle BAZ whenever we have arc AB. So we're going to use this problem to demonstrate what the formula is for finding angle BAZ. So that line, labeled M in the book, that has A and Z on it, is a tangent line that meets the circle just at point A. So our first step is to draw a diameter line from A. Okay, so this diameter line from A does two things for us. First, it cuts the arc of the circle into two equal halves, a 180 degree arc, and it gives us a 90 degree angle. Angle ZAC is 90 degrees. Now I have that labeled. This also gives us the arc of a semicircle. And what's the arc of a semicircle in degrees? Good, it's 180 degrees. And so we know that A to C is 180 degrees. Therefore, we can find B to C. 180 minus 80. 100 degrees. So, what's angle CAB with arc of 100 degrees here? Very good, it's 50 degrees. And so what is this angle? CAZ is 90. This part of it is 50, the rest of it must be 40. And so the rule will be this angle, or this arc divided in half, will be this angle. Writing that out mathematically, arc AB over 2 equals ZAB. Alright, on 12.16, we are given a problem very similar to the ones we solved last section, where we have an angle outside of the circle and two secant lines. Except in this case, we only have one secant line and one tangent line. However, we will see the formula you use is essentially the same. To demonstrate that we're using essentially the same formula, I'll draw a line from B to D. Arc BD is 110, and arc BC is 40 degrees. So we know that BDC is 20. To find DBA, we use exactly the same method we used in 12.15. Unfortunately, that method will give us this angle here. And so we'll have to use that angle to find DBA. So if you recall, this is Z. We know that DBZ will be 1/2 of 110, so it's 55 degrees. And DBZ is 55 degrees. Therefore, it's an exterior angle, making DAB 35 degrees, because the exterior angles of a triangle equal the opposite interior angles combined. And angle A is what we wanted to find in the first place. But as you can see, it is the same as saying 110 minus 40 over 2. And let's just work that out again using our normal formula for two secant lines. 110 minus 40, 110 minus 40 over 2 equals 70 over 2 equals 35. And so, since you don't want to work it out this very long and tedious way each time, you can just remember the formula. And applying this formula each time will give you angle A when you have a tangent line and a secant line that form an angle outside of the circle. Okay, last problem, 12.17. 12.17, we talk about when you have two tangent lines, what's going on. On this version, I drew 4 tangent lines that create two different angles just to demonstrate the same point twice. So the first time, we'll start over here. What we're going to show is that tangent lines from the same point, there's only 2 of them, and they're of equal length. And the way you show this is actually quite ingenious. So tangent lines go to the radius, and they're going to form right angles, of course. And then if I connect these lines, we are going to have 2 congruent triangles, because we'll have angle, side, side. So we have angle, side, and then this other side that they share. And angle, side, side, of course, is one of our congruence theorems. Therefore, this other side has to also be equal. And I'll demonstrate it one more time over hither in green. So this causes two right angles. I connect this line here, and we have angle, side, because all radiuses are equal, and side, because we have a shared side. And that proves that all tangent lines from the same point are of equal length. Alright, that's all you need to know for today. Thank you for joining me. Have a good one.